Welcome to Study Loop.
We know that force, magnetic force, is given by q times the cross product of velocity and magnetic field. So this means that the magnetic field is perpendicular to force, and if force is non-zero, then magnetic field the, cannot be parallel to the velocity. So basically, the component of magnetic field contributing to the force should be perpendicular and not parallel to the velocity vector. Now let's apply it to the electron and proton. So for the proton, so this is the first part. So let's say that B is, so the magnetic field has all three components. Now, for the proton, we see that force is along the y direction and velocity is along x direction. This means that the magnetic field should be perpendicular to the force, or j cap, and magnetic field is not parallel to the velocity I cap. So basically, the magnetic field contributing to the force. So, not the total magnetic field. This means that, so if this is if the component of magnetic field contributing to force is perpendicular to j cap, this means that we have two choice, I cap and k cap. But at the same time, it should not be parallel to I cap. So we just have one choice, which is k cap. This means that BZ is the one taking part in the magnetic force for the proton. Now let's move on to apply that. So Fp, let's call it Fpj cap, where Fp is just the magnitude of the force, is equal to Q times V. So this is basically Vp, which is Vxi cap, because there is no component along y and z direction. And the magnetic field, which in this case is Bzk cap, because all other components basically go to either zero or give the force in some other direction than y cap. So this will give q times Vx times Vz. Just a minute. Bz, right? Oh, sorry. Bz times I cap cross k cap. This is basically negative j cap. So negative qbx bz k cap. Sorry, j cap. And from here we can see that the magnitude is equal to negative qvx bz. This gives the magnitude of magnetic field along c direction to be Fp over negative Fp over q times Vx. We solve it and we get this value to be 1 point, sorry, this is negative 0.9375 Tesla. This means that the magnetic field has a component along the negative z direction because of the negative sign, and has a magnitude of this along that direction. Now it will be clear after we do the same thing for the electron. So for the electron, the force is along y cap and velocity is along k cap. So this means that for the electron, magnetic field should be perpendicular to j cap and not parallel to the velocity, which is along k cap. Let's not take the negative sign here into account because it doesn't affect much. We are anyway gonna include this while calculating the magnetic field. So here we see that there can only be two options for this, I cap and k cap, but it cannot be parallel to k cap. That means b cap is along I cap. So let's apply it now. So VE is equal to Q times VE vector, which is negative Vx k cap. So let's write it that way. Negative Vx k cap cross product with Bx because there is no component. So By and Bz do not contribute in this force. And this is basically VE j cap, which I forgot to write. Yeah. So this is Vx I cap, which gives Q times negative Q times Vx times. So this is Z, my mistake, Vx k cross I cap. And k cross I is j cap. So this is negative Q times Vz times Vx j cap. This gives Vx to be Fe over negative Fe over Q times Vz, and we get this value to be so Q is negative here because this is the charge of the electron. So we get this value to be 1.118 Tesla. Let me just write the charges over here. So QP is basically 1.6 times 10 to the power negative 19 coulombs, and QE has the same value but with a negative sign. That's the reason we are getting Bx to be positive here. Now we can combine these two and write the magnetic field to be, so Bx is non-zero, I cap, plus we have Bz, which is negative 0.9375 Tesla. This is along k cap, and By is gonna be 0 because we could not find it. And you can also follow this process by doing all the calculations. So you can take this value and you can apply this over here in this equation, and then you can choose which term is actually giving your force in the directions given in the question. So but that's going to be a lengthy process, and this one is easy because it's it's faster to figure out the direction of B. So that saves some time. Now from here we can find the magnitude of B, which is going to be Bx square plus B square root over of that by Pythagoras theorem, and this is equal to 1.46 Tesla. Similarly, we can find the angle of B with respect to the x-axis, positive x-axis. So this will be tan inverse bz over bx. This is equal to 40 degree, basically negative 40 degree. So the magnetic field, we can say that is magnetic field is in the xz plane, and it's directed at an angle 40 degree from the positive x-axis towards the negative z-axis because of this negative sign here. Now for the second part, we have by to be equal to 0 as we found from here. So basically we are gonna, sorry, basically we are going to use this equation now that we have the magnetic field calculated. So, and we have the velocity. So this is not necessary to write because we already have the magnetic field. And we are given the velocity, which is along the negative y direction. I'm just converting kilometers into meters. This is along negative y direction. And we use this equation that we wrote over here. So force is equal to q times, let's call this Vy because this is along the y direction, j cap cross the magnetic field which we found to be Bx I cap plus Bz k cap. And we get this value to be q times Vy times Bx j cap cross I cap. Sorry, there's a minus sign here, plus q times Vy, again a minus sign here which I forgot, q times Vy times Bc j cap cross k cap. And this is equal to negative k cap, and this is equal to positive I cap. And this gives the force to be negative q Vy Bz I cap plus q Vy Bx k cap. And q is the charge of the electron here. So we do the calculation and we find this force to be negative 4.8 times 10 to the power 16 Newton I cap, negative 5.724 times 10 to the power minus 16 Newton K cap. So the magnitude is gonna be Fx square. Let's call it Fc, root over of that. And we get this value to be 7.47 times 10 to the power minus 16 Newton. And we can find theta, the angle with respect to x-axis, is in this equation, Fc over Fx, which comes out to be 50 degree. So the force is basically in the xz plane here and is directed at 50 degree from the negative x-axis towards the negative z-axis.